We have the pleasure of having Gerl, Senior Building Designer VictorEric, to talk about some of the envelope elements in a high-performance house. For those who attended our breakfast series in May, you remember that in the second session, Joe talked about the general approach to design and construction of high-performance houses, and that was very well received. Now today he's going to talk about a few things more specifically and in more detail. I would like to thank Joe again for extending his time and expertise and pass it on to him for his presentation. Joe, take it away.
As Safir was talking about, I'm going to be discussing a little bit more about some of the more specific approaches, and in particular some more effective strategies for meeting the step code requirements. So to start off, for those of you who don't know, VictorEric is a premium design home company. We specialize in architectural, interior, and landscape custom home design, as well as offering construction management services. We've won a number of awards over the years for our work. We've been involved in the community, in the construction community, largely in the Lower Mainland, primarily in the Vancouver area for the last 15 years. And so we've really had a lot of experience in the area, really developing our craft and making sure that we're trying to set a better example for the construction community at large. Founder of the company is Eric Lee. Nothing goes out the door without his say. He is our creative director for the office, and he's been in the industry now for roughly 28 years. And he has seen, firsthand how quickly things have changed in this environment over the last 15 years, certainly. And so, we're always trying to rise to meet that challenge. And then there's myself, senior building designer at VictorEric. After taking part in the construction industry in the Okanagan, I spent 3 years working on Part 3 buildings at another office, and then the last 2 years I've been working on Part 9 buildings. So part of VictorEric's service is offering, fully integrated design, and what we use is BIM. BIM is a great tool for design and build, especially for contractors that are not necessarily part of our, if we're not building the project, then we can always invite contractors to come in and take a look and have a look at our model and make sure that everybody is in lockstep and has a good understanding about the mechanics and structure of the building, so that there aren't any surprises for the builder or for the homeowner. So if we say you're getting a 9-foot ceiling, you get a 9-foot ceiling, and there are, all the details are recognized and understood throughout the construction process. So part of the moving into the step code is making sure that you are developing a good plan early on and making sure that everybody is an understanding of that from an early period. So discussion topics today, really understanding the process, the importance of early integration, coordination, and communication, not only between the general contractor, but also with the site staff. We'll dive into a little bit more with the exterior insulation strategies, exterior air barrier strategies, and the thing that really makes this all possible is understanding how to incorporate structural integration into the building so that you can actually have an exterior insulation and exterior air barrier strategy. The reason we're having this discussion, in 2016 there was a Paris Climate Accord, and one of the things that they realized through a long and significant study was that the construction industry was largely responsible for 30 to 40% of the greenhouse gas emissions on the planet, and that is everything from the construction process to the life cycle of the building. So that's a lot of carbon output coming out of our buildings, and they determined that that is really something that we got to tamp down on. And luckily, the ability to be able to improve that does exist, and it was in the industry for quite some time. So now in Canada, we brought this step code approach in to try and reduce our greenhouse gas emissions through targeted energy performance standards. The real reason we're having this discussion, we've really only got one shot to really make a good go of this. So far, we haven't been doing that good a job of it. So it's really important that we all work together and develop a better standard so that our future generations can enjoy the planet as much as we have. So in that, the world is going high performance. This is just the direction of the construction industry. It's a natural progression, albeit it's happening a bit faster than normal. But with this, there are new ideas and a shifting mindset that comes with that. And so there has to be an understanding from the builder that once you're in the construction phase of the project, that really is the midpoint of the project itself. The design came first, and there's a lot of planning and conversations that come through that. So there is going to be a lot of change. How we design, how we build, and how we make decisions on site are really going to be important going forward. And again, it's that encouraging of collaboration between the build and design team to make sure that everybody is in complete understanding of what's expected on site and the types of envelope performance items that we're trying to hit. So this, again, is going to be quite important. In the past, simply put, there was a prescriptive approach. It was open-ended and there was no target. So for example, your neighbor's house could be built to the exact same prescription as yours, but their house could be producing way more greenhouse gas emissions than your house, even though you're using the same prescriptive approach. And really what that came from was, there's a prescriptive amount of how much R value your building envelope should have, how much, what your USI value for your opening should be, and then really any kind of mechanical system. And often what happened is through a lack of understanding or awareness or importance being placed on this, mechanical systems were often leveraged against building envelope. And there's a whole host of reasons for this, but I think largely it was due to a lack of awareness. Now, that being said, what ended up happening is because the building envelope was often sacrificed in lieu for a mechanical system, that meant that these mechanical systems were often installed in houses. They were often overbearing and overburdened and overrun. And then what would end up happening is the mechanical system would burn out far earlier in its life expectancy. And of course, with constantly running mechanical system, there's energy bills that come with that. There's the maintenance factor that comes with that. And all of these things could be avoided. And so what ends up happening is literally your money is going out the window. Living in homes like this are much more expensive. And of course, considering the end user, which is your client, end up, a little bit sad about this situation. So the better approach is going to be looking at the step code. So the step code has a more targeted approach, and the central arrow in that is the air change per hour. That is something that is incredibly important, and we'll discuss that a little bit more. But then there's the thermal energy demand intensity and the mechanical energy use index. And so what ends up happening with the step code approach is that it kind of borrows concepts from passive house, where in a passive house, you have little to no mechanical use, and you're putting all of your spending and capital in the house into your building envelope. But oftentimes what we found with passive houses is the construction cost is quite a ways out there. There's not a lot of familiarity from the building side as to what goes into a passive house. And so, oftentimes the cost of that is unattainable. But What does happen with the step code is that we sort of borrow ideas from Passive House and incorporate that into standard construction practice, and then maybe improve on some of those things that were lacking before. So with this kind of approach, you do start off with a little bit higher initial capital invested in the house, but the overall cost over time, there's a pretty good amount of energy savings. I know in the city of Vancouver, where we're moving to step 4, coming in January 2021, they're estimating that the payback period is roughly about 3 to 4 years for all of the upgrades in a step 4 house. So it's really not that much extra capital, and you're getting a lot more out of it. And so, of course, your client's happy because they're saving money. And if your client's happy, then you got happy builders, because you guys get to stay employed and you get to stay competitive in the industry. And again, if you can build to a higher performance standard for the house, you can market that to potential clients out there to say, like, look, we're able to deliver on high performance houses, so you should hire us because we're going to cost you less. Now, part of the thing to understand about the relationship between the designer and the builder is, this composer and conductor relationship. There is a relationship there where the two halves of this project really do need to work together. The builder can't be writing sheet music as the orchestra is playing. So it's really important that there is a direct line of communication with the designer early on, but also understanding that good decisions for building envelope and air barrier strategies are made during the design process, not last minute during the build process. And so this is something that we've discovered in our experience, is that we really do have to plan for these things early on, and then stick to it as we're going through the build process, because you don't want to run into a situation where suddenly you're in non-compliance because you missed some framing detail. So when does this all start? Well, it starts now. If you're not on board with this higher performance train, it's about time to get on board. But as far as how long this has been going on, a lot of countries around the world have been investing a lot of time and effort into bringing up their building standard around the world for at least 20 or more years now. So Canada is a little bit behind, and when in the earlier presentation to say that with respect to heat pumps that we're a small market, well, that's true, because Canada hasn't really been all that invested until recently in high performance and low greenhouse gas emission systems for homes. But there is really a point when this all starts, and that's the very first client meeting. There are a few things that need to happen in that client meeting to really set up a proper framework and really set a good foundation for the project. So during that first meeting, there's one of the things is the expectation. Now, part of the reason why I'm using this example is, if there is an expectation for how the building is meant to perform, but as a builder you're unaware of how to achieve that, you will get the reality version of this slide, and that's just something you don't want to have happen. It will cost you more money in the long run, because you have to fix all of these things at the last minute, and this is not good for the reputation. And then, of course, there is the desired element. Now, of course, as designers, we'd love to design a beautiful sports car of a building for every client, but the reality is a lot of us have lives that we lead that we're taking kids to soccer practice, or your kids' friends to football practice, doing Costco runs or last minute Christmas shopping runs for 12 people. So you need something a little bit more utilitarian that can stand up to that lifestyle. So part of this is understanding the desired versus required of a building process. So it is important to manage expectations and really be honest about the cost of construction. And the way that we do this is frame the discussion around the budget. And part of the way that you do this is interior items equal exterior items. So again, you have to, as a builder, discuss building envelope performance and glazing performance the same way that you would discuss, countertop spec and tiles and floor and, finishing aspects of the house. They are just as important for that visual impact for the client to really enjoy their home, but they also don't want to live in a cold, drafty home that's costing them, $200 a month more than their neighbor to heat. So it is important that these two things do come to the forefront now, especially with the step code. You can't sacrifice building envelope anymore because you want the extra designer tub or something like that in your house. You have to focus on these things early on. And part of the understanding that comes with that is that over the lifespan of the house, you may replace the kitchen cabinets and plumbing fixtures 2 or 3 times over the 10 to 20 years that you're living in the home. But really, you get one shot to make sure that your insulation and your barriers are done well and done to a good standard that really set the client up for success for living in their home. So that money that they're saving from a good performing building envelope, they can put that into the interior stuff down the road. So getting into it, there is that first element of structural integration design. And one of the things that you have to look at is strategizing. How your building components, and specifically how those relate to a building envelope, really relate to your structural elements. And you'd want to make sure that you're reducing thermal bridging, because this is going to be a big lag on envelope performance. The type of envelope assembly that you pick will have an impact on how your home performs. And so obviously eliminating thermal bridging, those direct conduits to heat gain or heat loss, eliminating that aspect from your construction is a massive help. The next thing is looking at bay windows and box windows, strategizing as to where those should go. And oftentimes the detailing around these elements is quite weak. So you don't want to go through this exercise of putting in all of this effort for the majority of the house, but then have these large swaths around the house that are poorly insulated. The air barrier doesn't work very well. The glazing is all leaky. So it is important to confer and discuss with your designer about where these elements best fit around the house. And I have to tell you, when you get into higher performance, when you're that step 5, 4+, step 5 passive house design, these sorts of elements start to kind of disappear. They do negatively impact your building envelope. So it's important that when you're in those lower steps, you are practicing and doing good work around these sorts of elements. And then the other one too that's particularly important: overhangs, cantilevers, structural projections, deck over living space. So how does the roof assembly tie into the wall and maintain your continuous exterior air barrier? How are you insulating that floor space that's cantilevered out over unconditioned space? And how are those details all coming together on site, but also through the planning process? And how are you as a builder involved in that to make sure that you understand the detail, understand what's expected, and then sharing that information with your trades to make sure that they also understand what's expected? So really the main aspect to this is keeping the primary structure warm. This is imperative to exterior air barrier strategy and exterior insulation strategies. And really what this means is sort of separating those internal structural elements from the external structural elements. So using ledgers and columns and beam structural components to help support those exterior elements and keep them separated from the interior elements. So that way you can really just wrap a nice blanket around the house and keep it warm. So yeah, air barriers. What is it? How it's used? Why is it important? First thing to understand is an air barrier needs to be 100% continuous to be effective. The understanding, of course, is that you can't have a hole in your air barrier, and I doubt there's been anyone out there that has achieved a 0.00 air change per hour, using an interior air barrier strategy. It's just something that's incredibly difficult, if not unlikely. So really having a good understanding of what an air barrier is, how it works, the difference between a vapor barrier and an air barrier is important. And it's about more than about just knowing that a vapor barrier goes on the warm side of the house, warm side of the assembly. You really do need to understand how important it is to detail an air barrier. So the difference between them: here's your air barrier, here's your vapor barrier. You can see that if you got a hole in your air barrier, that would be very detrimental to the performance of the person in that spacesuit. Whereas if you get a leak or a hole or something like that in your pool, you can patch it up and you'll be okay. Something to consider as why does this matter? So vapor barriers, they stop the movement of moisture across whatever that material is. You don't really get any kind of diffusion through that material either. Whereas an air barrier allows that diffusion. And so if you have a hole in the air barrier, it moves roughly 900% more moist air through it than, say, a hole in a vapor barrier, or just through regular diffusion in a vapor barrier. So it's really important that there is an understanding that holes in an air barrier, where it's that extra 900% of warm, moist air, is dollars. That's dollar value. That's greenhouse gas emissions. Those are things that are leaving and entering your home willfully without any kind of control. So really, something just very simple to understand is a leaky building lets heat out in the winter, allows heat in during the summer. This can get really expensive for the life cycle of the building. And, again, sad client face on this one. Air barrier materials, there's lots of them out there. Primarily, we use ProClima products, but, you can see there's a whole bunch of them out there. I've even included poly in here because, sometimes that is used as an air barrier. It is sometimes unavoidable. There are smart barriers here, and even concrete. The understanding that an air barrier is something you can't blow through. Well, concrete is also an air barrier. And it is part of your air barrier strategy. So it's important that you understand how those components all tie together. So selecting an effective insulation strategy is really the understanding. There are some basics here. Every wall assembly out there, roof assembly, floor assembly, is derived from these three types of strategies: interior insulated, exterior insulated, split insulation. And so you want to look at something like, say, deep stud walls, or walls that have TJIs as the structural element. You're looking at something that's an interior insulated assembly versus an exterior insulated assembly, which is really a category all on its own. And then split insulation is something that is a little bit more common in the industry. Part of that pragmatic approach that I bring to our work is to really, I have some understanding, given my work experience, that there really does need to be a pragmatism about what envelope strategy you're selecting for a project, because budget is a concern, and oftentimes exterior insulated insulation strategies are a little bit more expensive and they're a little bit more onerous. However, they are the safest approach. But split insulation is something that people are generally quite familiar with. And again, it's a very safe approach as well. It does have its drawbacks and risks, but interior insulated assemblies, by comparison, they do have weaknesses there as well. And understanding that the effect of a dew point on a wall assembly is something that can make or break the performance of a building. So when you're having all of your insulation in a cavity, you're going to get that condensation element potentially happening somewhere on your plywood sheathing, and you definitely don't want moisture and forming on your plywood sheathing. So it's really important to keep your structure warm, and so that's why this exterior insulated approach is the best way to do it, because now your structure is completely warm. Or you go somewhere, like I said, a little bit more pragmatic. You look at split insulation and still keeping that structure on the warmer side, but if there is condensation and forming anywhere in that assembly, it's likely happening somewhere in that exterior insulation, and hopefully you've used a material that is not affected too much by moisture and mold growth and things like that. So, there are a lot of assemblies out there. Some are better than others, but they are not all equal. So it's really important to think critically about the type of strategy you're using. What we focus on is typically using an exterior insulation in our building envelope assemblies, and what we really focus in on is the split insulated assembly. And so again, it's important. Details matter. What somebody does in the Okanagan or in Eastern Canada or in Germany, that's one strategy, but that doesn't always work in BC. So we really do have to think critically about what it is we're doing and how it is we're doing it. Out there in the world of support information, there is a lot of it. BC Housing does have some really wonderful guides to help the builders with understanding these components and the varying strategies for insulation and air barriers. Particularly one that comes up quite often, especially when you start adding exterior insulation, is the fasteners table, which is really quite effective. This is something that definitely will help that sort of concern, and even the budgeting aspect of what it takes to fasten, X amount of thickness of exterior insulation to your building envelope, and making sure that you're using the right screws and the right fasteners and the frequency and so on and so forth. So, these guides are very helpful. They're handy. They're readily available. And I do encourage all builders to really just have a minute and take a minute and read them thoroughly, and make sure you understand what it is that they're discussing. So now, we'll look a little bit at before we sort of dive into the detail aspect of things. One of the things that is really important is that as a builder, you're planning ahead before you start your construction process. Again, making sure that you're reading the drawings, you're understanding the details, you ask questions if you're unaware or not sure if something is going to work, can be sequenced properly. Communicate with your trades on site, set quality expectation from your trades to make sure that drywallers and electricians aren't destroying your air barrier if you're relying on an interior air barrier at some point. Making sure that if those holes are made, that they're patched up. It's just, these things can really make a difference in the end product of what it is that you're trying to create. Couple of things, or three things to really look at and focus in on when we're looking at details is structural design. How is it that for the overall approach of the building, how is it that the strategies that we're selecting for this will keep the primary structure warm, reduce unnecessary penetrations, and reduce thermal bridging? Exterior insulation, making sure that you're filling in the gaps and ensure that sequencing on site works. So again, this means that as a builder, you're having to think 4 weeks ahead and 3 steps ahead to make sure that you can build that sequencing aspect of the what's expected on site to make sure that you're getting the product that's been promised to the client, but also that's delivering on what's in the drawings. And then again, understanding that an air barrier, whether it's interior or exterior, needs to be 100% continuous and sealed. And the reason an exterior air barrier approach is effective on its own is because it's on the outside of the plywood sheathing. It's protected from the work of trades, and it's protected from a majority of penetrations. And maybe down the road, if the client decides that they want to renovate their house, they don't have to worry necessarily about most of the general public is unaware that maybe their poly vapor barrier is also their air barrier, and if they cut big holes in it and gashes in it and they don't seal it, they're not aware of the ramifications that might cause on their project or on their home. So locating that air barrier on the exterior is a matter of a little bit of quality assurance for the client, and it's peace of mind for you as the builder as well, knowing that you delivered something that is nearly foolproof. Something that we looked at a little bit in the last presentation a few weeks back was really just taking a basic shape of a house and identifying certain areas that are often very critical to air barrier and exterior insulation strategies. These are things that I've noticed in my experience are either missed or not accounted for during construction. So as a builder, again, it's going to be really important to sort of pay attention to some of these things when you're on site, and making sure that you sort of go floor by floor and make sure everything is getting checked. And again, before you start construction, reading through the drawings, checking the details, and understanding that for an air barrier to be effective, you should be able to take any section of a building and draw a line all the way around it and make it completely continuous, like this orange line here, using all the building envelope components that are outlined in the drawing package to create a continuous loop around the building, and that's how you know you have a continuous air barrier. Something that I have encouraged at the City of Vancouver, and I would maybe encourage for Richmond as well, is having some sort of accountability during the intake process and the review process to just make sure that the design team is able to identify their air barrier approach, their air barrier strategy, and just highlighting some of these key details to make sure that there is a detail on the drawings to help the builder set them up for success and make sure that they're going to hit these air change targets based on providing them with good details. Air change per hour is a significant portion, arguably one of the most important elements of the step code, and making sure that we're approaching that similarly and there's some accountability there, I think would really help as a standard for construction. So one of the first things that we look at, this one is relatively simple, but making sure that you're selecting XPS or EPS based insulation for the outside of the foundation wall, running your drainage mat down the face of that, and then waterproofing and damp proofing over the entire face of the footing. It just helps with the longevity and performance of the concrete foundation. As for the barrier materials themselves, you'll be looking at some amount of XPS or EPS below the slab, and making sure that you have a continuous thermal break here, bringing in a service cavity there. And then what we do is we use 10 mil poly underneath the slab and make sure that's sealed to the foundation wall. So as a builder, oftentimes, if you're just using 6 mil poly below the slab, it doesn't really stand up to some of that rigor of the construction process. It gets damaged by penetrations from rebar or tie wire, or maybe during the process of laying radiant pipe, or people dropping nails or tools or things like that onto the barrier. So it's it's good to use a robust material for this sort of thing, especially where it's once you cover it in concrete, you'll never see it again. So making sure that if there are holes in the material, seal them up before you pour the concrete. But again, using a good robust material like 10 mil poly will definitely help that quality control. And as a builder, you just have to make sure that you're leaving adequate laps of poly, so that way you can, bring it up a good, 3 or 4 inches or so onto your foundation wall and seal it, so that you can see that there is a continuous seal all the way around your foundation wall. And that that is sealed up real nicely. So one of the first elements of tying in your air barrier is going to happen where your wood frame wall and your concrete wall meet. So as I was mentioning earlier, concrete is an air barrier. This is part of your exterior air barrier strategy. And so you have to be able to tie your barriers to that concrete. So what this will mean in terms of sequencing is sealing using a self-adhered membrane on the plywood sheathing to the face of the concrete, then placing your flashing over that, covering the nail holes of the flashing with another piece of self-adhered membrane, and then bringing your WRB, your water-resistant barrier, so your house wrap, which would be functioning as the air barrier in this case, down over top of that, and then taping all of that to your flashing. And again, this is one of those things where there sometimes is a push to try and bring that flashing out to the face of the insulation, and that's what this detail here is showing. But when it's like, even when we're working on step 5 projects in our office, we found that if you're using high quality windows, triple glazed high performance windows, and your building isn't too crazy in its design, 2.5 inches of exterior insulation is all you need at step 5. So one of the aspects of that is to consider that if you are going to be putting your flashing on the outside of the insulation, you're really only going to be left with 2 or 3 inches of faced insulation material here, and trying to run a screw through your rain screen strapping and then through that and hitting the plywood sheathing, more often than not that insulation is going to split or fall off. So it's just not something that you really need to do in that sort of step 4, step 5, step 3 construction of the building. However, when you do approach passive house levels, suddenly that insulation is 9 inches thick and it's way out here. This sort of transition is starting 12 to 14 inches up the wall. Then maybe it makes sense to bring a counter flashing down across, because you don't want to have a 2-foot long piece of flashing material to try and tie that into your plywood sheathing. So for passive construction, this is something that you can do, but really for the step code level of building, putting that flashing and tying it back into your plywood sheathing is probably the way to go. Moving up the wall, when you get to box ends and mid-wall construction, this is one of those things where, because the insulation substrate is the same across the entire wall, it's your mineral wool or Gutex or Psycho or something like that, it's the same material. So you don't necessarily have to worry about that change between XPS and EPS to some other above grade insulation. So you can bring that flashing out to the face of the exterior insulation, but make sure that you do cut that exterior insulation, leave a good amount of slope there, and make sure that before you go and install all of this, that you are running a lap of exterior air barrier material up the plywood sheathing past the location of where that cut is going to happen, so that you can bring this the rest of the house wrap material down over top of that and tape it all together. and make sure that's taped over that counter flashing so you get a nice positive lap connection here. And again, make sure that that vertical leg of the flashing is behind the rain screen. It's meant to be draining excess moisture that makes it to your plywood sheathing. So it's not doing you any good by having it in front of the rain screen cavity. At that point, it's money spent that you probably shouldn't have spent. So again, putting that on the exterior insulation at this location is probably just fine. So looking at areas where you'll have a more than 3 and 12 pitch slope, pretty difficult, especially with a truss assembly, to maintain a complete exterior air barrier. So what often ends up happening is we transition to an interior air barrier, which means that you'll really have to, as a builder, pay very, very close attention to preparation of those assemblies and making sure that before, where you have, say, a roof assembly landing on top of a wall, or you have a roof assembly that's framing into the vertical portion of a wall, or you have a floor landing on top of a wall, making sure that you're adding those house wrap pre-stripping elements to the tops of the plates. Some builders, to protect it, they'll run it through in between the 2 top plates, but making sure that that material is there, because again, you get one chance to hit that exterior air barrier strategy. If you miss it, you end up defaulting to the interior air barrier, and when you're having to hit 2.0 or better for air change, it's going to be very difficult if you've got 1,000 penetrations in your interior air barrier. So again, making sure that you're capturing these transitions and making sure that you're not missing any of that is going to be very important to the exterior air barrier strategy. And then what often can happen is you can create a service cavity underneath. So again, protecting your air barrier. And what we would end up doing is creating a 5.5-inch drop. 5.5 inches because most residential pot lights are about 5 inches tall. So to avoid having to penetrate any of that interior air barrier, we make sure we have a service cavity that's deep enough that you don't have to worry about those punctures. The other thing to consider is that if you do have some sort of issue with the cold roof assembly, and you're having condensation forming on the plywood sheathing, and there's just something wrong there, oftentimes you have to go and look at all the penetrations from that poly vapor barrier and find out where the hole is and how that moisture is getting into the roof. If you don't have 300 different punctures of wires to worry about, and really your only penetration is your outgoing mechanical system, that really does narrow down the focus when it comes time for remediation, if that's required. So again, that service cavity is going to be quite important to make sure that you add that if you're in an interior air barrier strategy situation. Now, I get it. We know on the design side that ceiling height can often be an issue. Your client really wants 9-foot or 10-foot ceilings. So what you can do as part of that detailing aspect is adding an extra 5.5 inches to your top plates, and then bringing the bottom cord up 5.5 inches. So that way, when you do frame in your drop ceiling, you're not losing any ceiling height, but you are compressing some of that insulation that ends up here. So it would maybe require using a higher density insulation for that first 1,200 mils or so in that area to make sure that you're maintaining a good amount of R value in that detail. Let's see, here we go. Looking at flat roofs or shallow pitch roofs. So exterior air barrier and a split insulation assembly where we have some exterior insulation. Again, the continuity for the air barrier is very, very simple. The same material, if you're using a higher performance material like we're using ProClima, and that is rather essential to assemblies like this. Unfortunately for the guys at DuPont, relying on Tyvek for something like this is not really the best solution. It doesn't have the same performance ability as a higher performance air barrier material. And to be frank, the cost of the two different materials is really, it's like less than 1% on the construction cost. So again, investing in that better performing air barrier material is well worth it. So for a detail like this, you are still bringing that exterior barrier up the plywood sheathing, but you're now also bringing that same material just down over top of the plywood sheathing of your roof structure, and bringing it down over the face here, and then taping and sealing it. And then on the interior side, it's still good practice to detail this vapor barrier as an air barrier, because with any building envelope assembly, you can have 100 air barriers in your building envelope. You can only have one vapor barrier. So having that sort of fallback position in here, just in case there is something wrong with this outside material, likely there isn't, but just in case, making sure that you're sealing this material up and detailing it the same way as you would an air barrier, always a good thing, especially with flat roofs, because what ends up happening oftentimes is where you have these penetrations through your air barrier into the structure, there's warm, moist air that's making it into this cavity, and it's hitting the plywood sheathing, it's condensing, and it's creating what they call a convective loop inside that roof structure. And that's something that is really going to draw down a lot of the performance capability of the assembly. So in an ideal world, all of this insulation would be right up top here, but again, that can be rather expensive. It's more of a commercial detail that we see, or a passive house detail that we see. And so looking at it from both the ideal situation, but also the pragmatic situation, putting an extra 2 inches of comfort board 80 on top of that plywood sheathing, and then putting that in between your 2x overframing is really quite helpful to helping the performance of that, keeping that air barrier a little bit warmer, so that you don't have the condensation happening on your plywood sheathing. Now, as I showed, this this roof joist assembly here is going to have sleepers on it to form that slope. So it's important that when they do insulate that cavity, they're insulating it right to the underside of the plywood sheathing, just so that way you don't end up with any air gaps between your plywood sheathing and your insulation. Because if you do have something like that happen, again, it does invite the potential for condensate to form, but it also does severely degrade the performance of your insulated assembly. And then as part of the sequencing for that, again, it's important that when you do land your overframing on top of these walls, that you are filling in the gaps of insulation. And one of the things that I see missed quite often is this little space right here. Oftentimes they'll just put the block of framing down there, and then they'll put the plywood sheathing on, and that's it. But now you have this weak point here in your envelope, which doesn't really help anybody. So just taking a little bit of extra time and making sure that you put that extra insulation in here to maintain a similar R value across this assembly is going to be one of those things that, again, is noticeable in terms of the performance of the house. Because if you have missing insulation here around the entire perimeter of the house, that's a big thermal bridge. So it's important to not miss that. Now, the reason why this assembly doesn't have a service cavity underneath it, if you were to utilize the service cavity and not put any of this insulation out here, is because sometimes where that service cavity terminates in terms of interior design is rather problematic. So what you can do is maybe try and reverse engineer this a little bit. Take this assembly and push it up 5.5 inches, and then you get a nice service cavity that you can put it underneath there. But again, it is recommended for simplicity's sake that you just maintain the exterior insulation out there. That we have a nice continuous exterior insulated assembly around the building. But again, this does touch on the idea that as we move to more net zero approach construction and closer to that passive house construction type, practicing and understanding exterior air barriers and continuity of exterior insulation is going to be really important for builders, especially if you want to remain viable in the future. So understanding where these details occur and how to integrate them and make sure that they're sequenced properly is going to be quite important. And again, this similar situation is bringing that air barrier up and in behind where your flashing is going, self-adhered membrane over top of that, flashing on there, tape it over, bring that air barrier down, tape and seal it. This is all really important for maintaining that exterior air barrier continuity, because again, you don't want any holes in there. Just as a simple kind of graphic where we would have exterior air barrier connecting to interior air barrier and then back up into exterior air barriers before you go and put your roof truss framing onto the house, making sure you're putting your air barrier lap here so that it can tie into your interior air barrier. And then where you're having your jack trusses land and hit the exterior wall, making sure that the entire wall space up past where the top cord is going to land, making sure you got that pre-stripped with air barrier material as well is going to be really important. This is something that is often missed, and it is quite difficult to try and remediate that after the fact, because it really does mean pulling off your trusses. So putting that material down ahead of time before your trusses land, excellent thing to do, and that is like, if you as a builder are getting that detail right off the top, then congrats to you, because that's it's one that's missed quite often. So just make sure you are thinking in 3D in terms of the house and understanding sequencing and transitions, and again, reading the drawings, reading the details. If a detail is missing, ask the question. But also, not every detail can be captured in a drawing set. So it's important as a builder that you understand the concept of the air barrier and understand how strong of a concept an exterior air barrier approach is in terms of overall longevity of the performance of the house and maintaining the higher performance standard for the house to have an exterior air barrier. So understand the impact of really capturing those details and making sure that you're observing that on site. Now, when it comes to design in step 4, step 5 houses, not a whole lot changes between step 4 and step 5 home design. There are certain things that you have to watch out for, but the look of a house, and for designers and maybe for clients and for builders as well, when you're discussing these things, is the design it's not restricted to homes looking, just like this. This is also a home that we're working on that is going to hit step 4. So the design aspect of the house is still very adaptable and still very flexible. But again, during that planning process, it's important that as a builder, if you're involved in the project, to make sure that you're on the same page as the designers, so that when they're coming up with the assemblies and they're coming up with the details for their air barrier, that you're all in an understanding and a common understanding of what's going into that project and what's expected on site. And then, of course, as a builder, you can lend some of that pragmatic approach to the design side of things, that designers aren't drawing something that you can't possibly build. And then step 5 houses, this is one that we're doing in West Van. The form becomes a little bit more onerous, something that you have to watch, making sure that you're utilizing high performance glazing. Don't skimp on your glazing is a really important one to understand. And again, consider that if you have a hole in your boat, you're not going to try and patch up and beef up the boat. You're going to want to plug the hole. So windows and doors are essentially the hole in the boat. You don't want to skimp on those. You want to make sure those are performing really well, and make sure you got a good performance glazing package on your house in order to meet those criteria of higher steps. So in practice, for say a project that we're doing that's in step 3 here in Vancouver, this is on Elliott Street. One of the things that that you can look for in terms of what does this actually look like from details to in practice. And so looking at this house from the exterior, you can see where we have a flat roof up here. We have an exterior air barrier lap right at the top of this wall here that's lapping over the wall, and it's going to be transitioning to the interior structure. Where we have a canopy here and we have floor space that's suspended over unconditioned space. We have an exterior air barrier lap underneath there. So that way when we're bringing the air barrier up this wall, it can connect to that piece. We're bringing it up here, it can connect there. When we're bringing that air barrier over the structure here, it can connect there. And then what you'll see in the next slides is that that air barrier material is lapping its way up behind the exterior insulation and making itself available for a tie-in when we bring the rest of the air barrier material down. So what we'll do is I'll sort of take you through this project because this is going to be the most applicable to builders going forward, is those sorts of details in the step 3 house and the exterior air barrier approach. And again, the principle of exterior air barrier and exterior insulation doesn't change from step 3 to step 5 to passive house. The detail is relatively similar. The concept doesn't change. So what you're going to observe in these photos, it's something that you can sort of take with you in all of your projects. So first thing we'll look at is just what this kind of area looks like here. Then we'll look at what's going on with the tie-in up top, that sort of flat roof flashing and air barrier lap material situation. Sorry. Sorry about that. And then that transition to the interior air barrier here, what that looks like inside the house, and then what you can do around the perimeter of the house as well. So when you're, again, thinking in 3D, here's that tie-in there, where the air barrier material is lapped underneath the beam and lapped up the face of that beam, and then the structure is landing against that. Again, this had to be installed before the structural material went on. And then in behind that exterior insulation, it's coming up the wall and it's available here as a tie-in for that transition. So, just a little bit of prep, but that is very, very effective for the long-term project. Then along the perimeter of the house here, where we have that transition from a flat roof to a wall of the upper floor, there is a beam underneath there. And so we have our exterior air barrier material lapping underneath that beam so it can tie into the interior vapor barrier that's going to be showing up here. But, that material, again, coming up in behind the insulation, available to be tied into for the rest of the house. Then that exterior insulation being placed up against the building, and then your torch on going on there. And then the only thing that's missing from this now is that there will be a flashing that comes across here, and the barriers will be positively lapped over top of that to continue that continuity. The transition to from exterior to interior for roofs. So you can see along that whole perimeter there, it's completely sealed. And you can see just inside here, we have that exterior air barrier material lapped over the interior face of the studs, and then that vapor barrier material coming up the wall, sealing to it, and then running back underneath the underside of the joist. In the case of this project, we are having a drop ceiling in here. So service cavity wasn't necessary. We're not going to really have any penetrations through that material. If for whatever reason a drop ceiling wasn't going to be part of this assembly, then we would have put a 5.5-inch service cavity underneath this ceiling, just so that we don't damage this air barrier. 8.5 to 10.5-foot ceilings in this project, it's very doable if you only lose 5.5 inches. Around the perimeter of the building, that sort of sealing the sill detail, where we have a self-adhered membrane lapping over the concrete, and then that air barrier material coming down over top of that and taping and sealing that. Is one of those critical things for that tie-in for the exterior air barrier, is to make sure that you're tied in completely with the concrete, so you can get that continuity up the building. Here's a project that we have in Richmond on River Road. So this one, we made the decision after the framing was complete and the torch on was on, that there was a concern about sound. So the client is very interested in making sure that we're sort of doing our best to soundproof the home. So what we've done is we've added 3 inches of exterior insulation onto the house, given a deeper rain screen cavity to encourage drying. But then again, what we did use, along with the air barrier material up against the plywood sheathing, we also added a wind screen as well. And part of that sound attenuation consideration is that if you've got air kind of whistling through your envelope, anywhere where you have air moving through your envelope, it's going to bring sound. So, this is just a little bit of extra due diligence to make sure that we're blocking off any of that infiltration. And for a project like this, we're hitting step 4 quite handedly. I think in the case of this project, we were only under step 5 in one aspect, and I think that was the mechanical system. If we upgraded the mechanical system to, a heat pump or something more high performance, then we would have very handedly hit step 5. So again, you can see the design aspect of the house and the form of the house doesn't change too much, but the consideration and the understanding of what's expected of the house and what type of assemblies you're going to be using are going to be really important to understand and make sure that everybody is in complete understanding of that from the design phase. You don't want to be making these decisions during construction, because then you'll never get there. So I know there's a lot of information that kind of I've thrown at you here, but there is some comforting news. It's easier than you think. Like I said, so far, the few projects that we've tackled going into step 5, 2.5 inches of exterior insulation, and good performing glazing package. So some are passive certified, certainly get you there. 0.8 U value or better will get you there. So it's not something, step 5 is not something to fear. It's not something to be super worried about as a builder. There is a lot of support information out there. If you get in touch with a design build office that has the build experience and the understanding of budgeting varying strategies against the expectation and look of the building, you can leverage that experience to your benefit as a builder to make sure that you're delivering on what's expected of the project, whether it's the client's expectation for high performance or depending on where you sit in the step code, you're meeting that expectation from the authority having jurisdiction. And again, something that I'm kind of trying to get across to builders as well is that consider that if you're building homes right now that are the bare minimum meeting code, and maybe not utilizing exterior insulation, and you're sort of performing at that step 2, barely step 3 situation for the house. Imagine 5 or 6 years from now when homes are being built to step 5, and say coming into 2028, the person that had their home built in 2018 or 2019 is going to sell it. and maybe that all of the new homes around them are performing at an aspect that is not going to cost the homeowner so much to live in. If that conversation does sort of enter the ethos of how much is your home worth for resale value, I'm sure performance is going to be an aspect of that in the future. So it's important that you don't shy away or fear these sorts of elements of the construction industry. That you're staying informed and learning and reading, and again asking questions of designers, design builders, building envelope consultants, just really bouncing ideas off of them and making sure that you're staying in the know. So some of the main takeaways from this: planning starts from the very beginning. Everyone needs to get on the same page, and you need to calibrate expectations and the budget, and be realistic about what a project is going to cost, because too often we see projects being designed out there, and then the budget comes in and it's hundreds of thousands of dollars over what the client is expecting. And so then you start looking at, okay, where can we cut? And the first thing that comes to mind is, oh, we can cut the insulation, we can give you cheap windows, and we can change out the mechanical system. It's always building envelope, cuts always come first. So this is not a situation that you want to be in, and reacting like that to a situation that could have been resolved through a good understanding of the cost of construction. Early coordination and diligence during that planning process, that early bits of communication really do save money in the long run. It makes builds much more straightforward. And again, it does save the client money in the long term if they're living in a house that doesn't cost them so much to heat and cool. And not all assemblies and strategies are the same. Some are more reliable than others, and that's just science. So make sure that you're familiar with how certain assemblies behave versus others. Again, anytime you're incorporating exterior insulation, you're always on the right track. It's just cost aside, you're always on the right track on that aspect of construction. And in my past experience working on commercial projects where we used deep stud cavity insulation assemblies, where we're using like 2x10 construction, packing that with dense pack insulation, and then putting a service cavity on the inside of that. At the end of the project, when we priced that all out, it turns out that if we would have just stuck with 2x6 framing and put 3 inches of insulation on the outside of the building would have performed better, but it also would have been roughly the same cost, if not less expensive, to do that. So not all assemblies are the same, and it does really have to be more than just dollars and cents. It does have to be an understanding of performance. So going back to what I said earlier, don't sacrifice envelope. These practices do cost less than you think, and it's just a matter of trying it and practicing it, especially now when Richmond is in step 3 for the average Richmond builder. It's going to be important to practice these concepts now while you have the luxury of time on your side, because I tell you, once you hit step 4 and step 5, if you're not comfortable with exterior insulation, it's going to be a rude awakening for you. And again, I've found out there that there is this equivalency of high performance immediately meaning passive. Essentially what high performance does is borrows from passive house ideas. Take the ideas of reducing thermal bridging and incorporating exterior insulation and using a durable, high-performing air barrier material and putting that on the outside of the structure. Those are ideas that are borrowed from passive house, but in no means is 2 inches of exterior insulation a passive house assembly. So don't be afraid of high-performance practices. And again, details, details, details. Ask questions, work smart. Think about what it is that you're doing when you're on site, and again, ask questions and make sure you're reading the drawings. So yeah, I just want to thank you for your time, and I believe there's a question period after this, so I will be more than willing to answer any questions that you folks might have.